You know, every single time you log in, buy something, or send an email, you're trusting a massive, invisible system built entirely on secrets. But have you ever wondered how those secrets are actually made and how they're shared safely? Well, we're going to pull back the curtain on all that. And you're going to find out about the surprisingly chaotic secret ingredient that keeps your entire digital life from falling apart.
I mean, it's the fundamental question, isn't it? When you connect to your bank's website, you need to prove you're you. And just as important, your bank needs to prove it's really them. The tricky part, you have to do all of this out in the open, on the public internet, where literally anyone could be listening in. So how in the world do you create a private conversation in a very, very public space? That's the puzzle we're going to solve today.
You see, if the internet was just a tiny village, this would be simple. You'd have a secret handshake for every person you wanted to talk to. But the internet isn't a village. It's a planet with billions and billions of devices. Trying to create and remember a unique secret key for every single website, every server, every device you interact with, it's not just hard, it's a logistical nightmare.
Yeah, a system where everyone's on their own just collapses under its own weight. The number of secrets you'd have to manage would be insane. The solution, and it's a pretty brilliant one, is to bring in a trusted third party, a key distribution center, or KDC. This central hub just simplifies everything. All you need is one master secret to talk to the KDC, and it handles all the introductions for you, brokering all your other conversations securely.
Now, this idea of a trusted middleman isn't just a theory. It's the engine behind a system called Kerberos, which you've probably used a million times without even knowing it. The best way to think about Kerberos? It's like the ultimate bouncer for a massive, exclusive, members-only digital club.
So to make this really concrete, let's imagine you're at a big university and you need to print a sensitive research paper. You can't just send it to any old printer. You have to prove you are who you say you are and that you have permission to use that specific printer. This is a perfect job for our bouncer, Kerberos. It's this clever three-step dance. First, you go to the main bouncer, the authentication server, and you prove who you are with your password. In return, it gives you a master ticket. Then you take that master ticket to a second bouncer, the ticket granting server, and you say, hey, I need to use the printer. It gives you a special one-time use ticket just for that printer. Finally, you walk up to the printer, show it your ticket, and boom, you're in. What's so genius about this is that it neatly separates proving who you are from proving what you're allowed to do. So this whole system of bouncers and tickets is incredibly powerful, but its entire strength hangs on one tiny detail. What are those tickets actually made of? Well, at their core, they're just encrypted strings of numbers. And if an attacker can guess or predict those numbers, they can forge their own tickets, walk right past the bouncers, and the whole security system just crumbles. And that brings us to the real secret ingredient here. Predictability is the absolute #1 enemy of security. It's that simple. If an attacker can figure out the pattern in your secret keys, it's game over. This means that your digital life, all of it, is only as safe as your computer's ability to generate pure, unadulterated, unpredictable chaos whenever it needs it. And this is the great paradox, isn't it? I mean, we've built these machines to be monuments of logic and order. The exact same input will always produce the exact same output. So how on earth can we ask this machine of pure predictability to create something that is, by its very nature, completely unpredictable? Well, the first thought was, okay, if a computer can't be truly random, maybe it can just fake it. Maybe it can run a clever algorithm that spits out a sequence of numbers that looks random enough to fool everybody. These are called pseudo-random number generators. One of the earliest and simplest methods was basically just a mathematical recipe. You start with a secret number, the seed, then you multiply it by another number, add a third, do a little modulo math, and out pops your next random number. Then you just repeat the process. It's super fast, super simple, and 100% deterministic. But here's the fatal flaw. Because it's just a simple, repeating recipe, the numbers it spits out will eventually fall into a loop. And sometimes it's a laughably short loop. For cryptography, for security, this is absolutely catastrophic. An attacker just has to watch a few numbers go by, figure out the pattern, and suddenly they can predict every secret key you're ever going to make. Okay, so if faking randomness with pure math is a dead end for security, we need something else. Instead of trying to create chaos from order, what if we could find chaos that already exists in the real world and just sort of bottle it up? This is the whole idea behind something called entropy. So, what is entropy?
Put simply, it's just a measure of unpredictability. In the world of computers, it means harvesting all the tiny, chaotic, messy events from the physical world, things that are fundamentally not predictable, and using them as a source of genuine randomness. It's like having a well of pure chaos on tap.
So where does your computer find all this chaos? This part is amazing. It's literally listening to the world around it. It measures the tiny microsecond differences in the rhythm of your typing. It tracks the little unpredictable jitters as you move your mouse. It looks at the chaotic arrival times of data packets from the internet. It even listens to the random static, the thermal noise generated by its own electronic parts. All of this messy, real-world data gets collected into something called an entropy pool. And this harvested chaos is the raw material for what we call truly random number generators. See, unlike their pseudo-cousins, these numbers don't come from a predictable formula. They come from the messy, unpredictable physics of the universe. And that is what makes them strong enough to build our entire digital world on top of.
So, we have the perfect secret ingredient, true randomness from entropy. It sounds like we've solved it, right? But there's a catch. There's a critical moment in a device's life where this well of chaos can be bone dry, and that creates a really dangerous vulnerability known as the entropy hole.
Okay, picture a brand new router fresh out of the box. You plug it in. The very first thing it has to do is generate a private key to secure itself. But think about it. What chaotic real-world events has it seen? Nothing. No one has typed on it, no mouse has moved, no network packets have arrived. Its entropy pool is completely empty. So, in desperation, the router generates a key using the only information it has, its own predictable, factory default startup state.
And this is not just a theoretical problem. A major study that scanned public keys all over the internet found that a shocking 0.5% of all secure web servers had weak, predictable keys. And why? Because countless different devices, all starved for entropy right at boot up, had accidentally generated the exact same random numbers to create their supposedly unique secret keys, and that makes them incredibly easy to crack. So here's the bottom line. Your entire digital life is protected by secret keys, which are really just random numbers. The strength of those numbers comes directly from the universe's own messiness, harvested by your machine. It's this beautiful, fragile system that depends entirely on having just enough unpredictability at exactly the right moment, which leaves us with one pretty important question. Is your device chaotic enough when it really, truly matters?